Hello, welcome back to Learn Physics. Today's topic also we are continuing with the work, energy and power. Next question is, work is required to lift a body through a height from the ground. Calculate the work done in lifting a body of mass 10 kilogram to a height of 10 meter above the ground. See, to lift a body of mass 10 kilogram. So it's an easy question. Mass is 10 kilogram and height is given as 10 meter. How you can find out the work done? Work done will be equal to energy. That is, here it is potential energy. What is the formula to find out the potential energy? mgh. So it will be 10 into 9.8 into 10. So here it is 980 joule you will get. Clear? So the next is, state and prove the law of conservation of energy of a freely falling body. If an object is falling down, what will be the, so you should state and prove the law of conservation of energy. Right. So here the total energy will remain constant, isn't it? That is law of conservation of energy. Total energy before collision and after collision will remain constant. You can use the Newton's second law of motion and prove that. Okay, for two objects you should consider MA and MB. So that and all detail we already learned. So derivation and all now I am not doing. Using Newton's second law and third law, FAB equals minus FBA. Using that you can prove that. Okay. Then so here state of law of conservation. This is law of conservation of momentum only you will be proving in such a manner. Law of conservation of energy, how you will prove? See, if an object is falling down at different positions A, B and C, what will be the total energy? That one you can find out and you can prove that total energy will remain constant. Next is, draw the variation of kinetic energy and potential energy with height of the object. See, with the height, how we can find out? Draw the variation of, see, this is x. So this is the potential energy or in kinetic energy. Maximum height potential energy is maximum. So this is potential energy graph. Okay, kinetic energy means at the extreme position, that is minus x and plus x. What will be there? Kinetic energy will be least 1. So here at this position and it will be maximum at 0 position. So it will be like this. Okay, so but the total energy always remains constant. This is total energy, this is kinetic energy. Understood? So x and minus x positions, extreme positions, potential energy will be maximum. At the position of 0, kinetic energy will be maximum. So this is the variation of energy and this is about the position. So here it is asked, draw the variation of kinetic energy and potential energy with height. As height increases, potential energy will be increasing and kinetic energy will be decreasing. Next is, state and prove the law of conservation of energy for a freely falling body. This is the third time which we are explaining that. So next is, draw graphically the variation of potential energy, kinetic energy with respect to height. Next question is, that one in improvement also it is asked and in March also it is asked. That is why twice it has come. Next question is, according to the work energy theorem, work done by a force on a body is equal to change in kinetic energy. A lorry and a car moving with the same kinetic energy are stopped by applying brakes which provides the same retardation. Which of them will come to rest in shorter distance of time? Explain. See, here a lorry and a car moving with the same kinetic energy. If kinetic energy is same, which kinematic quantity will remain same? Kinetic energy we know it is half mv square. Okay, kinetic energy same means velocity is changing over here. Right. So with same kinetic energy are stopped by applying brakes which provides the same retardation. Retardation is same. Okay. So acceleration remains same. Which of them will come to rest in a shorter time? Okay, half mass of car into velocity of car square will be equal to half into mass of lorry and velocity of lorry square. Half and half will get cancelled. So now see, it is given like same acceleration, retardation is same, right? So negative acceleration is same. We can find out v square minus u square equals 2as. It is coming to rest position, right? So it is 0 minus u square equals 2 into minus as, because this accelerate, it is retardation. So u square you will get it as 2as. Here you can substitute for u square. So mc into 2 into acceleration of car into distance travelled by the car equals mass of lorry into 2 into acceleration of the lorry into distance travelled by the lorry. But acceleration remains same, they told. So 2a and 2a we can cancel since they are same. So here we will get it as mc into sc will be equal to ml into sl. That means mc into sc, m into s will be a constant. M into s is a constant. That is, distance travelled will be inversely proportional to m. So as mass increases, distance travelled will decrease. Always don't take this one. You can in this condition, that is if retardation remains the same and kinetic energy remains the same, then distance travelled will be inversely proportional to mass. That means as mass increases, distance travelled will be decreasing. Okay, so for which one will be travelling a shorter distance? Lorry will be travelling a shorter distance since its mass is more. Clear? Next is, if the kinetic energy of a body is doubled, what is the percentage change in linear momentum? So kinetic energy is doubled. So kinetic energy dash equals 2 into initial kinetic energy. Okay, what will be the percentage change in momentum? Kinetic energy and momentum, what is the relation? In previous videos we did p square by 2m. Right, so P's kinetic energy dash will be equal to 2 into kinetic energy. So I can substitute it over there. Okay, of a body. So P1 square divided by 2m will be equal to 2 into P square divided by 2m. Same body, right? So like this it will be getting. So here 2m and 2m will get cancelled. P1 square, P1 equals 2 root 2 into P. Okay, what is the percentage change only it is asked, right? So P dash minus P will be equal to root 2P minus P. P into root 2 minus 1. P dash minus P divided by P into 100. That is equal to P divided by P into root 2 minus 1 into 100. So the answer you will get it as root 2 minus 1 into 100. So while you are solving, since you have a calculator, you can solve that. See here, root 2 is 1.414 minus 1 into 100. So you will get it as 0.414. So 41.4 you will get. Okay, this is how you should find out the percentage change. So now the new momentum you got, if it is getting doubled, if kinetic energy is getting doubled, what will be the new momentum? Root 2 into P. Now change in momentum. Change in momentum, percentage change means if initially this was the momentum, now the change in momentum is this much into 100. You can solve it. Clear? Next is collision, consider a body falling freely through the atmosphere, neglecting the air resistance. Prove that total mechanical energy of the body remains constant throughout the fall. In yesterday's video we did, and today also twice it had come in the many years question paper. So it is you can consider it is an important question. Okay, at the position A, B and C, everywhere we will get it as mgh when it is falling down. Okay, so that in yesterday's video also we did, right? So you can do that. Collision between two particles need not be physical contact of two particles as in the case of scattering of alpha particle by a nucleus. What is the quantity that remains conserved in all types of collision? Elastic collision or inelastic collision, which quantity will remain same? Momentum will be remaining same in all the collision. So linear momentum will remain a conserved quantity in elastic collision as well as in inelastic collision. Suppose an electron and a proton are projected with equal kinetic energy. What will be the ratio of their linear moments if the proton is 1830 times heavier than the electron? This one we will do. So here we are considering electron and proton. Okay, then are projected with equal kinetic energy. Kinetic energy is say E. And we know mass of electron is different from mass of proton. Now, what will be the ratio of their linear moments if the proton and electron is if the proton is 1830 times heavier than electron. So mass of proton is equal to 1830 times heavier than mass of electron. Ratio of their linear moments. So linear momentum and energy, mass, including that, what is the equation? Kinetic energy equals P square divided by 2m. So this is an important equation for your questions because many times using the equation, many questions in different ways they asked. So don't forget to by heart this equation, okay? So energy is same but momentum is different. So Pe square divided by 2me will be equal to, since energies are same, we can equate Pm square divided by 2 into mass of proton. Okay, so here Pe divided by Pp will be equal to 2 and 2 will get cancelled. Me divided by Mp. Okay, what is Me? Mp will be equal to 1830 Me. So we will get it as momentum of proton will be equal to 18 into 1830 Pe into Pp equals, so momentum of proton equals 1830 into Pe. Okay, here the question is asked, find the ratio of their linear moment. So Pe divided by Pp. In question electron and proton is given. So it is momentum of electron by momentum of proton will be equal to 1 divided by 1830 or 1 is to 1830 will be the ratio of their moments. Okay. Next is a bob of a pendulum released from 30 degree to the vertical hits another bob of equal mass at rest. How high do the first bob rise after collision? Assume that the collision is elastic and sizes of the bobs are negligible. This is elastic collision, right? In elastic collision, momentum and kinetic energy are conserved quantities. If both are conserved quantities and second one is at rest. Second bob was at rest. Okay, and first one is coming with a particular velocity and will be hitting it. What will happen? This second bob will be getting all the velocities of first one. So after that what will happen? It won't be rising. Okay, after that it will be moving with the same velocity of the first one. Okay, all the velocity will be transferring to the next one. So it is not moving its height. All the velocity, the first one won't be rising, but instead of that it is transferring all the velocity to the second one. So the next question is, work is related to the force and displacement over which it acts. A man tries to pull a rigid wall for a long time but fails to displace it. what is the external work done by him. So if he is pulling for long time, displacement is not happening, means work done will be equal to 0 over there. Suggest two conditions for the work done by a force to be 0. Work done will be 0 when and all work done will be 0 if F and S are perpendicular to each other, or if displacement is equal to 0. These two conditions, work done will be equal to 0. Next question is, a body of mass 1 kilogram travels in a straight line, a velocity v equals k x to the power 3 by 2, where k equals 5 SI units, and calculate the work done by the net force with displace from x is equal to 0 to x is equal to 2 meter. So we need to find out the work done. Work done, we know what is the formula? Change in kinetic energy, that is half mv square minus half mu square. Right, mass is given as 1 kilogram. So first we need to find out v and u. V means we should substitute final distance. U means we should substitute initial distance. So u we will get it as 0. What is v here? K into k is 5, x to the power 3 by 2. Okay, 2 cube is 8, square root of 8. Now what will be the work done? Work done, half m v square. 5 square is 25 into 8 minus 0. So here 25 fours are 100. You will get the work done as 100 joule. Okay, clear? These are some of the questions from this previous year question paper. So in next day I will be coming with the system of particles and rotational motion. Okay, so I think it is useful for you, and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.